Okay, great. I'm going to be talking about some recent updates that are ongoing for the SWOOSH data set and what that means for the variability and trends. And a lot of this work is motivated by the expected loss of the AURA microwave limb sounder sometime in the next 0 to a couple of years. So for those who aren't familiar with SWOOSH, SWOOSH is the Stratospheric Water and Ozone Satellite Homogenized Database. It's a vertically resolved, gridded, monthly mean water and ozone data set, similar to some of the data sets we heard about in the last talk. The data for SWOOSH all comes from limb profiling instruments going back to SAGE 2 in 1984 and continuing to the present with AURA MLS. And for most people, the primary product of interest in SWOOSH is the merged data record, where we've made an attempt to combine the ozone and water from these various satellites. But SWOOSH also contains a number of additional pieces of information, including the individual records themselves from each satellite, as well as a number of different statistical and uncertainty-related metrics. So SWOOSH is available on multiple different grids. Primarily, it was kind of created as a zonal mean product, and it's provided on a couple of different zonal mean grids, and also on a vertical pressure grid. In addition to that main product, we also produce it on equivalent latitude and isentropic grids, as well as some very coarse longitudinally resolved grids. So this schematic here shows what goes into SWOOSH that I mentioned: SAGE, HALO, URs, and SAGE 3 on Meteor, as well as AURA MLS. That was the product as of 2016 when we first published the paper describing SWOOSH, and the current version of the data is maintained and updated monthly at the CSL NOAA page here. What I'm going to be talking about in this talk is what we're calling 3.0. It's actually currently 2.7, which is really the kind of current state of things. And then once we finalize it, I think we'll call it 3.0. So I'm kind of using those interchangeably here. So the things that I would like to highlight that are updated are that we're using some new versions of existing data sets that went into SWOOSH. We have entirely new sources of data, new satellites. We have some updated screening, and then some new additional information, gridding, and uncertainty estimates. For the existing data sets that we have now moved to MLS version 5, which we've already heard about a little bit earlier. And the kind of expected changes for that are primarily on the water vapor side of things, related to reducing a drift from the earlier version of MLS data. I'll show a few slides on that. And we're also now updating to include the latest ACE data. So what does this actually mean for the trends that are in SWOOSH? The impact of the MLS version 5 data is quite minor through most of the stratosphere. Within it changes the trends by less than 0.5% per decade, except for some small region down in the tropical upper troposphere, where there is some apparent change between the two versions of MLS that we're still trying to understand better. It's the actual difference is plotted here, and it looks like some of this drift between the versions has occurred over the last 5 years. But for most of the stratosphere, the ozone from V5 is quite similar, so there's very minor changes. On the water side, things are quite a bit different. There's on the order of about a 3% per decade reduction in the water vapor trends going from 4 to 5. So this is a really big change. And so it's easy to see when you compare the two versions of SWOOSH with the two different versions of MLS. But another way that you can look at this is to actually compare it to a model. So in this case, looking at a Lagrangian trajectory model, which is used in a lot of papers by Mark Schoberl and Andy Dessler, where parcels are initialized and driven by the MERA2 temperatures and winds, and you fill the domain. And so here we're looking at the entry value of water vapor, and it's almost hard to distinguish the lines because they're so close, but the trajectory model and the swoosh data agree amazingly well on interannual timescales with one another. And you actually kind of have to difference the swoosh data from the trajectory to see differences very well. But if you do that, you see that there is a time-dependent offset between swoosh and the trajectory model, and that when you go from the 2.6 to 2.7, so going from MLS version 4 to 5, there is a slight reduction in the trend with time compared to the trajectory model, but it doesn't entirely eliminate those differences. So this is broadly consistent with what Nathaniel showed in his paper on the version 5 water changes a few years ago. Okay, so I talked about some of the data updates and what that does to swoosh. I now want to pivot and talk about a couple of new sources of data. We heard about SAGE 3 yesterday, and we are now including the SAGE 3 water and ozone data from version 5.3 into swoosh. And the other very major change is the inclusion of the OMPS limb ozone data. And I'll say a little bit about that. So the OMPS data provides several thousand profiles per day. So it's kind of on the order of the data quantity from MLS. And we're currently pulling in the SOMI MPP OMPS, but JPSS was launched last fall and will be added when that becomes available, which we hope will be soon. The idea going forward is that OMPS will become the primary ozone data source for swoosh after MLS goes away. And the reasoning for that is in part that OMPS is actually planned to operate out through the 2030s and generally is expected to be suitable except for a lack of polar night measurements. So recently, as in a couple months ago, version 2.6 of the NASA OMPS data was released, and it's a pretty strong improvement over the earlier version 2.5 in terms of reducing the drift. And I'll advertise a poster by UAGIA today, and Natalia's going to talk on Thursday about this. So I'd refer you to their presentations for more information on the new OMPS. Okay, so we have some new data. We're also planning on adding that's going to, I think, be really interesting for the pre-Aura MLS period of swoosh. So we're looking at including both the SABRE data, SABRE water vapor, and OSIRIS data to fill out some of the pre-Aura MLS period. And the reason for that is kind of illustrated in this plot, which shows the number of profiles going into swoosh each month. And this huge jump of 2 orders of magnitude is MLS. And in this pre-MLS period, really any additional profiles we can get, even from solar occultations where you're not getting quite as many, is really helpful for the data set. So we're exploring adding more data into swoosh. And so now the picture for swoosh looks like this compared to what we had earlier. So these top data sets are all what's in swoosh or what will be in swoosh shortly. And then I know this is not an exhaustive list, but there's a number of possible instruments coming in the future that I'm excited to hear more about this week. Okay, so I've talked about data now. I want to say just a little bit again a little bit of a focus on this pre-MLS period. So in the intervening time from when we originally put together Swoosh to now, there's been some discussions about various data screening for some of the early data sets. And the bottom line is our earlier screening was arguably a little bit more conservative than it needed to be. And so we've relaxed some of the screening of Sage 2 and Sage 3 Meteor going into Swoosh, and that increases their amount of data they're contributing by somewhere on the order of 10 to 20% for ozone. In particular, the Sage 2 screening is based on some work done by Stephanie Crimser a few years ago, looking at filtering the data in a more kind of physically based way using line of sight optical depth for ozone. And that really has added back a decent bit of data in the earlier period. Okay, and so now maybe the more exciting stuff is really looking at kind of new things that we're doing, and a number of these things in orange are things that are kind of ongoing, and so they're not set in stone yet, but we're thinking about them. So we have added methane and N2O into Swoosh for people who are interested in looking at age of air type studies in the stratosphere. We're looking at raising the lid of Swoosh to 0.1, and part of that work involves having some kind of accounting for the diurnal cycle in ozone, and there's a little bit of that in UA's poster you can see today. We're also looking at sub-monthly Swoosh gradings and improved uncertainty estimates, both for the individual satellites and for sampling related effects. So I'll briefly say something about the uncertainty issues, and these are challenging issues that have been around for a long time that many people are aware of, but there really is a need for consistent uncertainties across instruments, and this plot shows why and what happens when you have inconsistent estimates. So this is a water vapor time series from one grid in Swoosh, and we show the error bars showing essentially what you get if you do a kind of propagation of errors approach for the monthly mean as these narrow bars. And you can see in some cases for some instruments like MLS, those are quite similar to the standard deviation of the data itself. And then in some cases, those that sort of propagation of errors gives you values that are wildly larger or much smaller than the standard deviation. And so if you try to apply this approach, if you try to apply this type of propagation of errors approach into a merged data product, you get something that is kind of wacky and is shown in this dark gray shaded line here. So you can have periods of time where it looks maybe arguably reasonable and then gets extremely large, and then you have a different instrument for some period of time that makes it extremely small, so small you can't even see it. And so we have been doing some work looking at empirical adjustments to these individual source uncertainties to try to essentially homogenize them, and that's work with Alex Lang at Karlsruhe. In addition to the source uncertainties, we're well aware of sampling uncertainties, particularly for time periods where we're relying on solar occultation instruments. And so non-uniform sampling, we know, can lead to biased estimates within some grid box. And so this is just kind of a cartoon schematic of that. If all of your data points are on the edge of the grid box, then your mean of those points gets biased. And so what we've done so far on this is actually we are now storing the mean latitude and time of each observation from each instrument in Swoosh. We're also storing the mean latitude and time of the combined product. And so that information could be potentially fed into a regression for people who are using this data for regression work. there is also a possibility of using this to give you a better uncertainty estimate or for even correcting this sampling bias. So those are things we're still actively investigating and trying to determine how we want to implement. Okay, so just to summarize, the new swoosh, we will be adding, effectively adding data in the data sparse pre-MLS period through some new instruments and through changed screening of existing instruments. I've shown you a couple of things showing the impact of MLS version 5 and how that impacts the trends. Primarily, that is a large effect in terms of water vapor trends. We have a number of ongoing efforts at improved uncertainty and methods for swoosh, and then a lot of this is really motivated on the upcoming loss of Aura MLS that we expect in the next couple of years. And for the future, OMPS will be our primary ozone. We have, between SAGE, ACE, and SABRE, we have water vapor that will maintain in swoosh as long as those instruments are still alive. But we do have an expectation that we will have a period of significantly reduced water vapor coverage in the coming years. So with that, I'll stop.